All right. So let's start with the class. I see the questions coming in the chat, and that's fine. I might not be able to answer your questions now, but if you have any question, put it in the chat box, and I will address them one by one. I'm very sorry with the confusion around Zoom and the way it's been established. We are also very new to Zoom, at least I am very new to Zoom. This is the first class I'm teaching with Zoom. So there were supposed to be a few issues. And then we have 4 TAs, but they all had been waiting for their contracts and they didn't get their contracts until last night. So it became a lot of administrative burden on us on how to kind of fix all these things. But I'll just take these 2 questions we have in the chat now, and then we can start with the class. Well, when it comes to groups for lab, yeah, you're kind of free to choose the group you're going to work with. We might, depends on the assignment inside the, during the class. It's not really an assignment, but during the lab work. The lab work, sometimes they're very independent. Like today lab work we're going to have, so be very independent. Sometimes it will be based on the group, but it's mostly on you, so you choose. But when it comes to assignment, then we are kind of strict on making a group, being in that group, and then you could reuse the same group for the project as well, so no problem. All right. You're welcome. All right, so let's start. In the previous lecture we had on AI, we discussed how the statistics on AI. What we wanted to show was how grand AI is becoming, the scale of AI, how much investment is going in, how many institutes are interested in AI. And I hope that kind of showed you in a way how AI is here to stay. But that also means we also need to identify that AI. So in today's class, what we're trying to identify is that there was a time when AI was a huge buzzword. Everyone was talking about AI. Most of them didn't even know what AI was, but everyone, like, there were startups coming around, and if you wanted to raise some capital, some cash, all you had to do was put a name AI at the end of your startup, and investors went crazy for your startup. They will give you millions of dollars. Things were good. I'm so glad we're not in that phase anymore. People know more what AI is. Investors know more of that, and AI, it has more become like a hidden force. It's like computer engineering, like software programming. Software programming is not, so when you launch a startup, when you launch a product, you're never going to say to a company that hey, we are actually our product is a software engineering product, or our product is so cool because we have used Java in it, or we have used C# in it. You never hear these things, but you still hear people saying like, oh, we have used AI in our product. I don't understand this, because AI is just like software engineering. This is programming. So why would you highlight your startup so much? You should highlight your end product. You're making headphones. You're making AirPods, for example. Your end product is an AirPod. Your end product is not an AI-based AirPod. You would never sell your product saying like, we made AirPods which use cutting-edge software engineering in it. But unfortunately, that's how we perceive AI right now. So we lose the focus on the product itself, and we jump onto what AI is. But I think give it a few more years and people will become more mature and more understanding about it. Anyway, the lecture for today is based on what AI really is. I think it was a bit premature for us to jump into the statistics of AI. And now today we're going to discuss what really is artificial intelligence. So what's the whole hype around it? What's the difference between AI and computational simple programming, for example, and simple basics around AI? So what I would advise you is that even if you have, like in the last class we had, one of you actually asked what was cloud computing, and that was a very good question to ask, because in my head I would assume, I mean, for you to understand what artificial intelligence is, it's very important for you to understand cloud computing. And for some reason, I assume you know what cloud computing is, and that's like I didn't really understand it well. So I'm also changing the slides as we go along. I'm changing the course content. So please take the chat to ask as many dumb questions as you can, because those questions will actually give me an idea on how to structure the content. Even though I say dumb questions, they are not dumb questions. So every feedback you give will be an improvement towards the course. All right, so let's proceed. It's very important in artificial intelligence to identify intelligence. So then what really is intelligence? What do we define intelligence as? And this is not about computers at all. This is about intelligence in your daily life. What really is that? How would you define intelligence in your daily life? Do you think you're a smart person just because people around you? Yeah, some people would say that, right? Or yeah, we like to act smart in our daily lives, and everyone in their own context would consider them intelligent or consider other people intelligent. But apart from all the memes that are out there, one of the definitions I like is, I don't know if this is actually the right meme or not, but it's this kind of kind of pops out, and I do agree with this when they say like the measure of the intelligence is the ability to change. If you learn and adapt, that's how you become intelligent. If you keep on doing the same things over and over again, um, it's intelligent in its own way, but then you haven't really learned anything from your environment in order to move forward. But if we put the means aside and we take a look at how psychologists would define intelligence, it's kind of divided into three different areas. It would be based on your ability to learn, how well you can actually look at things, you can learn how they're shaped. If you see a problem, how well can you solve a problem? And the third one would also be the ability to recognize problems. And then it takes us all the way back to the philosophy of a child, of a baby. And I think it's a very nice analogy when you compare a small child, a small baby, with artificial intelligence. The way a baby looks at the world, the baby looks at the problems, and then the baby tries to solve those problems. And then while solving those problems, the baby also learns that the last time I solved the problem in this specific way is exactly how intelligence is being formed in that baby. And all those impressions coming in the baby is at the same time. The baby is learning whatever is happening in the world around the baby. And that's intelligence, That's how we as individuals become intelligent in our lives, because we learn, we adapt, we see a problem and we find a solution to it. We want to reach from point A to point B, and there are like thousands of ways to go from one stop to the other stop. you could either walk, you could either take an electric scooter, you could take the bus, you could take the train, you could take your car, you you could just hitch a ride. And every time you choose a path, you go there, you learn how your experience was on that ride. Your experience might be very good or might be very bad. Your When you started your journey from one stop to the other stop, perhaps in the train, you didn't have a nice experience. So the next time you go, you will probably skip the train and just walk. By walking, perhaps you got tired and you were like, no, I don't want to walk again. You probably want to take an electric scooter, and so on and so on and so on. Intelligence also kind of is dependent on your past actions. It's, of course, intelligence is based on how well you solve problems and how well you learn. But if you keep on doing the same thing over and over again, that will become an intelligent thing for you. Now, hear me out. Like, intelligence is a very subjective thing. Intelligence, what might seem intelligent to one individual, might not be intelligent or that smart to another individual, and that's fine. We don't really care about what others think in that context, because everyone has their own context. Um, so so what we are focused on is like, in the history or in the time span of an individual, that individual went through a specific series of that individual took a series of impressions, learned, and with uh, historical um, and with the history of reapplying the same actions, the person or that individual created their own environment, and that became the best case scenario for that individual, and that became the intelligence for that person as well. So when we talk about, all right. Yeah, please, if there's any problem with the sound, just let me know. Okay. So, so that's the concept of intelligence, which has been applied in artificial intelligence as well. So what we do in artificial intelligence is that we take the same concept of intelligence, which exists for us as humans, and we try to put that concept in the machines as well. And that's where the word artificial intelligence comes in. So AI is basically taking some sort of intelligence and putting it artificially into the machines. What we are also trying to do is, we're trying to build machines, we're trying to build software which can behave like humans, more like us. We're trying to build machines which can make decision-making capabilities on behalf of humans. We don't have to, so we're trying to build machines which can act on their own. We don't have to go in and tell them every time to do this, this, and this. And we're also trying to build a machine which learns on its own. I kind of like to take the example of using AI in stock market, for example. Perhaps that's not really a good example, but a lot of work is being done nowadays on trying to predict how the stock market will move using artificial intelligence. And one of the biggest things they work on is, um, they focus on the biggest problem humans have when it comes to owning a stock is like, for example, you bought like Apple shares, everything is fine, the stock is going up, but let's assume you bought them in 2007, and 2007 to suddenly the time when there was a huge market crash. The stocks started going down. There's panic in the street, and now you are thinking, I just bought like 2 days ago. Should I sell my stocks or not? And you have a hope that Apple is a very good company. The stocks will go back up, and this is just a temporary market dip. Everything will be back to normal. And we as humans have this fear in us, like uh, this fear and this hope that things will come back to normal, and this is just an individual thing affecting the market. But then a few days pass and the market has dropped almost 50%. And now you're really freaking out. Now you're like, what should I do right now? Should I sell now? I've already lost 50% of my investment, or should I hold on? Then the same thing, the hope comes back to us humans. We'll be like, how about, I mean, it's 50%. The market will bounce back. It's a stable company, right? A few days pass more by and the stock drops more 25%. Well, not 25%, some more percentages more. So within a span of almost 2 months, the stock is down almost 75%. Now you've almost given hope. Like you're like, now, I mean, I've already lost 75%. Why don't I hold it for a very long period of time? Yeah, and that is probably the smartest decision you have made until the whole process now. Like now I should hold. And that's the difference between a human and the machine. A human when making the decision would be based on, there's a lot of emotion which will come in. There's a lot of fear factor which will come in, and then a lot of hope which will affect their decisions. But when you give the same deciding factor to a machine, and then you give them a decision-based capability, which would look at the historical data, which will look at the meta information, and look at the overall market going down and coming back up. The machine would be able to take a much faster decision than humans can. That's why artificial intelligence makes it much more easier. Now, the people who bought the stocks in 2007 or 2008, they held on to the stocks. It took them almost 10 years to come back to the same, and this is in reality what happened. It took them almost 10 years to come back on the same level of the market, which the market was when it dropped in 2008. Yeah, and then the thing is, we humans also learn on our own. We learn on what happened in our past. So if you have been trading stocks, you have learned and you have picked up along the way that when a specific financial report comes out, that specific stock will be affected because of that financial report. You could also learn on the way that some people, when they're traveling in July, summertime, it's actually a nice time to sell your stocks and be on the side. These are things you learn while trading stocks. This is the same way AI in stock market is also learning on their own. They're continuously being fed with all this information. They're being fed financial news. The algorithms are being fed historical data input. They're being fed. There are a lot of quant traders who are working on stock market trading. And because of that extra information, the machine or the algorithm keeps on learning. And when it learns more, it's able to act much more faster than humans. So that takes us to another definition of AI, and that would be AI is actually a software which can solve a problem without any human instruction at all. So it will be more independent in that way. What we would also like to do was, I would like to identify how AI is different from conventional programming. And this is a very important thing to highlight. Every one of us are coming from, most of us are coming from a programming background. And with the programming background, we are very used to looking at a problem. We look at a problem, we know what kind of output it's going to be, and we try to build the algorithm around it. And the algorithm is very focused on the problem itself. But that's not how AI programmers work. um, the AI programmers look at the problem, uh, and they also look at the AI. They try to solve. They try to use the AI algorithms, but they leave it to the AI algorithm to find a solution. So then there's more. You have to try it over and over again, one time, two times, three times, and there's so many times you have to go over and over and try to find the solution. So the thing is, with the traditional software programming, you're 100% sure that this for this input, that would be the output. For example, if you're making an algorithm for programming a keyboard, right? And for every punch the user will give in, the keyboard in front of you, it has Q, W, E, R, T, Y symbols on it. In your software application, in traditional computer programming, if you press Q, the output would be Q. If you press WERTY, the output will be WERTY. You're 100% sure about that. Nothing can go wrong unless and until the algorithm is really messed up or there's a bug in the code. But in an AI application, what happens is that if you press Q, you're not 100% sure the output will be Q. You have a percentage prediction score saying that if I press Q, I am 80% sure that the output will be Q. I'm 90% sure, I'm 40%, 50, 60, 70. You can never be 100% sure with an AI application that this input will generate this output. And that's the difference between traditional computer programming and AI. And then you retry it. Same goes with WERTY. When you do press those keystrokes, your application might be able to produce the same output, but you can never be 100% sure. And that's where AI algorithms kind of succeed. That's where they kind of stand out. That if I were to come to you and I would ask you, what's the success rate of your AI algorithm? You then what I'm asking you is the prediction score, the percentage score, and your answer would be my algorithm works. My algorithm has a prediction score of almost 80%. That's how you define how successful that is. But that's not for all AI algorithms. That's a specific field of AI. More specifically, supervised learning, unsupervised learning as well, but the branch of machine learning. All right. That kind of is the same point I was explaining earlier, that the programmer would have complete control over their application, but an AI programmer can never claim to have full control over AI applications. And that's a problem, because if you talk about explainable AI, you want to be able to explain how you made this application. For example, you're making a very normal application which most banks and finance institutions are working on is the credit score. They're also working on how would you call it, financial, I can't remember the name, but it's kind of based on that every person who has a bank account has a credit score attached to them. I have a credit score, you have a credit score, everyone has a credit score. That credit score kind of explains to the bank how risk averse that person is. So if I go to the bank and I ask them for a loan, or for my for my car or for my house, they will look at my credit score. And the credit score is actually a small score, which will tell them that how safe am I as a customer to the bank, and how will I be able to give that money back. That kind of credit score used to be based on hard-coded rules. But now most of the banks are using AI to score that credit score. And the problem, of course, AI gives you much more flexibility, and it kind of gives more power to the programmer. to the application. But the problem is that when it comes to explaining how that credit score was achieved, it's very hard to explain how that was achieved. No one can actually go in and tell or explain how that application, how that credit score for that individual was achieved. So um, it's very easy to explain simple algorithms which are done with traditional computing, but it's very hard to explain like AI-based algorithms. The other thing is that AI applications use a lot of search and pattern matching. Like if the algorithm was shown a bunch of balls, then everything which is round, everything which is of the same size, everything which is of the same color, for example, that is the pattern matching for AI applications. And the AI will actually assume that this series of images are actually balls. The same goes for cats and dogs. Um, AI, and that's why AI has to look at historical data just to find patterns among the data, and then try to predict that this is the right object I'm looking at. Yeah, and when it comes to conventional computing, the most important element is the algorithm itself. This is something we have been learning in all our education. You learn Java programming, you learn C#, you learn Kotlin, JavaScript, whatever, and then you learn about algorithms. You learn about how to optimize an algorithm, how to work on backend programming, front-end programming. You actually learn the basics of programming, and you also learn on how to further optimize your code, how to deploy your code. Then you have cloud computing. Then you focus on infrastructure, builders, and all that. But the difference, and that's exactly the same in AI as well. But what makes AI a bit more complicated is that you also have to add in data. So you do the same thing that you do in conventional programming. You look at the program, you look at the language, you look at the algorithms, you pick up the best algorithms, you try out different algorithms, and you deploy the application, put it on cloud infrastructure, use a GPU, for example. But if you don't have the right data to train your AI algorithm, your AI algorithm will not work. So I've been talking to while conversing with a few startups. Most of the startups I communicated with, their strategy was they would, like some startups, when they get some funding, the first thing they do is they try to jump on the most hype technologies in demand. And I've seen this mistake being done with a lot of startups. What they do is that they start looking for AI programmers. They don't even have a product. They're looking for AI programmers, and the reason is very simple. Because investors, when they give in like some investment, they're like, you should get the best talent to build your product. And they're like, yes, why don't we start looking for programmers plus AI programmers, and then we put them together, and then they can make an amazing product for them. The problem with that approach is that you have a startup doesn't have any product yet. A startup doesn't have any traction. Even if you launch the product, initially 1 or 2 years, you might get like 100 users. And the problem with the 100 users is they are not creating enough data for you. So how can you build AI applications if you do not have the data? If your application is as simple as an image recognition application, which would be very simple, like you're making a camera app for your phone, which uses AI in it, then it's fine. Then you already have tons of data sets available on the internet. You can download them, put it to your camera app, and it will work fine. But if you're making a very sophisticated application, health app, for example, and you don't have health images because they are private, you can't just download them. Then you need to have those health images first, and then create the AI application. So focus on the data. If you don't have the data, there is no AI algorithm. You cannot just work with with AI applications or algorithms at all. I like this comic a lot, and that's the biggest problem. Like, this used to be a huge problem a few years ago, People misused AI a lot. Again, now the investors are more, the investors, general population, programmers are more smarter than before. But you will still get people who would kind of um, try to convince you that if else statements are also part of AI. It kind of amazes me that we still have this discussion around this topic, that if else, yeah, I mean, if else is also kind of a logical implementation, but we're training the machine to learn from its past. All right, this map, I found this map on the internet. It's not something I made, and I think it's very smart. The person who actually made this map is just brilliant. This is the map of computer science. I don't think it covers almost every element of computer science, but the person has done an amazing job in kind of identifying different areas of computer science. And if you look at this small box, that's where AI comes in. And the reason why we are showing this map is to give you an idea that AI is just a field of computer science. It's not something new or something different. It has to work with existing elements of computer science. You have all the way, like from CPU, FPGA, you have GPAs, then you have programming languages, then you have operating systems, then you have applications on top of them. You might have supercomputing, augmented reality, and then all the way you get like AI applications. You have computer view, image processing, robotics. What one is that? A knowledge presentation. Yeah, thank you. NLP. Is there NLP there? Yeah, that's NLP there. So it's very important to identify that AI is part of computer science. AI is not a field on its own. And for some people, this is very obvious, but for some, it's actually not at all. Because when you talk about AI, and you talk about computer science, you still have to follow the same rules and principles as every other branch of computer sciences. Everything is so interconnected that one thing cannot exist without the other. I remember like one startup I was advising on when it came to AI, and they came up with a very simple and very simple question. Their requirements were very clear on what kind of product they want to make, but when it came to AI, they did not understand AI at all. So that's the time when AI was really much in hype. All the media outlets were talking about AI and how AI is going to change the world. And this person asked me, like, they start with the very simple requirement that, yes, we want to create a product. We want to create a product which will, these are our users. This is our need. This is their need. And this is the product we're going to make will satisfy their need, and everything is fine. They had a fantastic team. They were hiring some programmers as well, but with the AI part, they were like, it was a black box to them. So their question to me was very amusing, and the question they asked was like, how can we use AI to make our software products more autonomous? Because they've been reading so much news and they've heard so much hype about AI that they thought that by using artificial intelligence, they will be able to create software which will exist on its own. So once programmed, the software will keep on developing on its own. There's no need for human intervention, and in the future, their whole IT department will actually shrink to 1 or 2 persons because they're using AI in their product development. and that kind of made me smile, and then I kind of felt sorry for those people as well, because um, that that kind of showed that they they were they were thinking AI is some kind of a magic box, that you put AI in your computer applications and it fixes everything, and that's not really the case. The problem with AI is that if you start working with AI, it's actually more complicated to work with AI algorithms than traditional computer algorithms. And once you start working, with a simple computer application, you have a start date and an end date. With an AI, if you're programming an AI application, you have a start date but no end date, because once you deliver the product, you put it into production, you have to retrain it, you have to monitor it, and you have to keep on monitoring it, because even one small garbage data can mess up the whole AI application. Um, and actually having an AI algorithm, working on an AI algorithm is actually very expensive for the company. So that was the most clear view example I got of how uneducated people were when it came to the benefits of AI. And that's your role, that's your role as AI programmers. That's something you have to do while educating different people on what AI can or cannot do. This is our duty. We know how computer science works. We're now learning how AI will work as well. Yeah. Does anyone have any questions? I was thinking we'll take a short break. I'll go and fill up my coffee, and we can meet up at 9:30. That works well. Should we take a break then? All right. All right. So I'm gonna pause the recording and we'll meet again at 9:30. Right, how do I? Hi, so I'm just looking at the chat now. Let's look at the questions which came in. Yeah, I see a few students are talking about we know that there's a clash between this class and a few other classes, and we're very sorry for this clash. We don't have any good solution except to move it to some other days. When it comes to the labs, so I do feel this makes you more of a disadvantage when it comes to the lab work, which would happen after the class. But it's not really, the lab work is not really that dependent on what you have studied in the class. They are related, but you don't have to have taken the whole class to be able to do the lab work. The aim for the lab work is to get you up to date or kind of explain to you how AI would work. So there's a lot of help available in the lab material in itself. So I wouldn't say the classes and the lab work are connected. So you can do them later at your own pace as well. What I can do is, the thing is, it also depends on how many people complain about affecting their classes, because the more people who complain, the better it is. Then something can happen. So what I will advise you to do is, if you send me a private message, do it on Slack or do it on email. And I also have received some complaints from 2 students earlier. So if I have a substantial number of students complaining about clashing with their class, I can then take it to the admin and ask them to actually change it, or bring it back to how it was earlier. But the problem is it will still be the same thing, right? We'll have one class on Monday, which is 8:30, and the other class on 10:30 on Fridays. That's the best solution they can come out with. But let's keep an open channel on this. And that's one of the reasons why we are recording the lectures. So people who cannot take their class, they can do it afterwards. But we'll make sure that even if you come later to the class, there's no obligation that there's no, like, the lectures and the labs are like independent. Okay. So regarding the class which happened, which missed the last Friday, which some people missed the last Friday, I did send out an email informing everyone that there won't be a class last Friday. There's a possibility that you probably have an email overload, and you probably missed my email. But so what we have is there's two modes of communication which we are using: Slack and through email. For the most important, and now I don't send emails mostly on, like, I don't like to send a lot of emails, but when it comes to announcements or most important messages, I usually do it through email, because I'm assuming everyone will check their emails, even if you miss it on Slack. But if there's any other way which you are used to with your other classes, please let me know, and I will try to fix that as well. Just to confirm, is everyone on Slack now? Is everyone signed up on Slack? Well, please don't say yes, because there'll be a lot of yes coming back. But if there are people who are not signed up on Slack, could you please do that? We're almost 100 students on, all of us combined are 100 people on Slack, but the strength of the class is 140 combined. So there's still almost 40 people who haven't really signed up. The thing is, we might, when we start engaging in more discussions, more chat or Slack, then those people won't get the same information. So it's important that everyone comes to Slack. Okay, coming back to the class. 1 second, I'll just check. Everything is in order. Okay, so let's talk about the fourth and the biggest industrial revolution. The thing is, as history has taught us, there were three biggest industrial revolutions which we have had. The first industrial revolution was water and steam, and that kind of replaced humans and animals who were powering the machines, and that gave rise to steam engines, that gave rise to water engines, and so forth. Then the next industrial revolution we had, that was electricity. And electricity was a very cool industrial revolution. It changed a lot of things. It changed the way I mean, electricity become like an integral element of everything. That was a huge revolution and a huge step forward. That happened in 1870. It's not so far away from 1784. The third industrial revolution, which happened, was automation. That was in 1969. Now, automation was a turning point. Automation was also the point where you had a lot of machines coming in. There was a huge fear factor amongst people that they're going to take their jobs. You had a lot of cars fully becoming automated, supply chains becoming automated. You also saw the advent of internet. You had personal computers coming in. That was a very nice time, actually, 1969. That truly pushed us into an era where we are sitting now. That was a golden age of automation, in my opinion. And then we're talking about now, like the fourth industrial revolution. What we're talking about is not really only driverless cars, but we're talking about actually connected systems, cyber physical systems, um, smart systems, Internet of Things. And specifically, if we are talking about the fourth industrial revolution, we're talking about connectedness and smartness of things. These are the two keywords we're actually focused on. We're trying to make devices which are smart, which can exist on their own, but which can also communicate with other devices and make others devices smarter, and also learn on how to proceed forward. Um, some people claim we're already um, in this time right now, and some people say like we're still very far off. We still have a lot to achieve. Um, I'm not sure if we are fully there yet. When it comes to driverless cars, when it comes to how smart they are, I think driverless cars are very dumb. They're very stupid. They're not fully autonomous at all. So we're not really there yet. What driverless cars have done is like Tesla or other autonomous cars, like they have become smarter in their context. Like they have given more um, features to the end user, which are much better than the previous car industry ever gave. But when it comes to a fully autonomous car, we don't we see a few examples by Google, we see a few examples by Uber. Tesla is also claiming a few things over there, but we don't really see fully autonomous cars yet. There are a lot of human laws on how we should drive on the car, how long should we have our hand on the steering wheel, um, and a lot of human errors, um, which still kind of limit us on making our ability to deliver a fully autonomous car. And the algorithms and data themselves are not really that advanced yet. But the other thing, IoT devices, that's a very interesting area. Does everyone, okay, you know what, I'll just tell you what IoT is for those of you who don't know. IoT is actually Internet of Things. IoT is any smart or small device which you can connect to internet and start collecting data from it. For example, a very small example would be your smartwatch. Your smartwatch is an example of an IoT device. Your headphones, wireless headphones would be an example of an IoT device. Anything which can be connected to the internet is an example of an IoT device. In router, for example, we use sensors inside the bus and the train. So when you enter the bus, and any bus, as soon as you enter the bus from the door, um, if you haven't seen it, the next time try to look at the sensors. You probably see a few sensors on the top of the door, and you also see some cameras over there as well. So what we do is we try to figure out how many people are entering the bus and how many people are exiting the bus. And these sensors connected in the bus are sending live data back to our servers inside router. So we have real-time information of what's happening inside the bus, how many passengers are there, and that's how we know how many buses are overcrowded. And for some routes where there are like a lot of passengers giving on a specific time, we try to send more buses there. So these sensors are becoming more famous because they are being deployed everywhere. They've been deployed in image sensing, like in cameras. They are deployed if you want to make a home more smarter, they're used over there to make like in your heating devices. If you get into a room and you want to talk to your Google Assistant or Amazon Assistant, they're available over there. These things are taking off. You don't hear them so much because these are very tiny things and they don't make such a huge impact. But if you collectively count how many IoT devices we have in the world, the figure is really humongous. And when you combine all those and you see how much data is actually coming from those devices, it's huge amounts of data. and then you can use that data to work on your AI application. That helps a lot. Okay, so any questions on until now? Good. So let's talk about the history of AI. It's important to identify what happened with AI, or how AI actually came into being. Um, there's another slide of lectures I'm going to upload later today that talks only about history of artificial intelligence. It will be nice for you to read through them. This is just for reference, and try to kind of educate yourself more around the background of artificial intelligence. But today I'm going to talk about, there are two slides we're going to focus on AI. So the efforts, the person who started, or who actually started artificial intelligence, well, not one person, but a team of persons who actually started it, that was introduced in 1955. But the efforts to create the first intelligent machine started as early as 1642. And yeah, so I mean, all our lives we have been trying to create intelligent machines which can help us, do our jobs. But it was only in 1955 when we were able to identify that as a specific field, and we called it artificial intelligence. This graph is also very nice. Again, I didn't make this graph. So the link where I picked it up is actually in the reference area. But the thing is that 1955 was a time when we started working on artificial intelligence, or we gave this a name. They were like, we want to make intelligent machines, and let's call it artificial intelligence. From 1956 to 1974, everyone was about it. Like, yes, we should create artificial intelligence. This is the right thing to do. So you had a lot of government funding coming in, and that could be considered as like the golden time of AI. However, the problem was that the promises of AI were good, but what AI could actually deliver wasn't really that up to speed. So then we see a downturn, or AI winter, as we call it. That was from 1987 to 1993. So you see investors not putting any money on any development. You don't see government putting any funding on it. So everything kind of froze. Now, from 1980 to 1987, something interesting happened. Instead of working on artificial intelligence, knowledge-based expert systems started coming out. Now, these systems were not really AI systems, but they gave the way to becoming more, or creating more AI applications. A knowledge-based system is a system which works on a specific domain problem, fixes that domain problems, and moves on. You could also call a knowledge-based expert system more like if-else statements. And that's one of the reasons why if-else statements, some people still call if-else statements as AI, because they became popular in 1980 to 1987. And knowledge-based systems kind of were like, all right, people were like, forget AI, focus on knowledge-based systems because they give us some value, immediate value. Oh, shoot, I'm going the other way around. Okay. Anyway, let's jump on to 1993 to 2011. What happened was that in 1993, we had increased computation power. You also saw, like, in the 1990s, Silicon Valley, the whole industry was being set up. You had companies like Apple coming out, Microsoft, IBM was already there, but chip processing became widely available. The price of chip went down, microprocessors came in, and because processing power became so cheap, it was easier to do a lot more calculations on even a CPU, that we started thinking about AI. One of the most important things to highlight is, like, I remember when I was working on my first Java application, working on my Java application, like an assignment for my class, the thing which we had to struggle the most was RAM. Um, Java application or JVM was very bloated back in the day. And every application you wrote, you had to focus on how much memory you consume. Um, and within a lapse of 4 years, I remember like the first year, the second year when we were working with assembly language, C++, and Java language, um, our focus was how can we optimize memory? How can we make less use of the storage space and make sure that we make effective algorithms? The focus was creating effective algorithms. But within the lapse of 2 to 3 years, we started talking about creating enterprise applications. And when you talk about enterprise application, you do not talk about memory, you do not talk about storage, because that's the same time chip processing became more cheaper. Um, and then the focus went away from creating better algorithms to creating powerful algorithms, which would consume more memory, which would consume more CPU power. That's that's the shift, and that's what also eventually gave rise to iPhones or smart devices, Android phones, um, because it was we were able to create more powerful devices, more powerful chips, which could do processing much faster. So 1993 to 2011 was a turning point, just because it became uh, processing power was more cheaper. And then 2011, even earlier than that, I think that was around 2007 and 8, when cloud computing came out. Um, and as we have discussed earlier, like in cloud computing, instead of buying a full hardware, you rent out a space in the cloud. So if you're working on an AI algorithm, instead of paying like 500,000 kroner for buying GPU, buying RAM and everything, you just pay like 2-3 thousand kroner for a couple of hours. You rent that GPU from a cloud provider. You train your algorithm on it, and everything is fine. Um, from 2012 and onwards, this was a time we started seeing IoT devices coming in. We saw Facebook, um, social media. We saw a lot of internet companies coming in, which were collecting massive amounts of data and making it available for others to consume. We saw companies like Cambridge Analytica coming in, which started consuming this free data and producing valuable insights, or actually for their political clients. Of course, it was bad, but I mean, there's so much data available now with so many services. You can just point to one service, start consuming their data. Router, for example, we consume data from SSB. We consume data from Statistics Central Bureau. We consume data from EAR, EAR.no. We consume data for almost every open source government repository, open data government repository, because data is freely available. Um, and the thing with this data is, like, previously you had to think about, all right, I have 1 gigabit of data. Where am I going to store it? How am I going to consume it? What am I going to do with this data? But now, when you have so much data coming in, you don't think about storage at all. We pick the data, we dump it on our data warehouse, and we never think about it again. Because now we're not paying in gigabytes of data, we're paying for terabytes of data. And terabytes of data per year would cost you around, I don't know, 100 to 1,000 kroner per year. And that's a very cheap cost to pay for even terabytes of data. So no one is shy of consuming data. You want to consume more data. You want to process that data. You want to make it available in a nice format so you can use it further in your services. I remember in 2012, a lot of companies started charging for their data, but the data, I mean, there were so many companies producing so much data that after a while, companies stopped charging for their data. And now only proprietary companies like Facebook, who actually sitting on golden data, would charge for their data sets. But open companies like For example, you could even start collecting data. Just create a simple blog. Um, Start producing some content on that blog, and put some trackers on your blog. Um, like Google Analytics would be a very good example. And even if you have 2 or 3 people visiting your blog, you can get so much information on how they behave on your blog, which areas of the site they will click the most, and so forth. And that data, then you can make useful reports on that data, or you can use that in your machine learning or AI applications and try to predict how users will behave on your site. That's so so that's the thing. Like 2012 to today, um, mainly because of a lot of data became available, computation power became easily accessible to everyone. We had huge breakthroughs in fields like machine learning, natural language processing, deep learning, and um, AI finally kicked off. And that also brings me back to my previous thing, that the amount of money flowing into AI has been increasing since 2012. It peaked in 2018. It went down in 2019. One would have assumed that 2020 is also a bad time, but you know what happened in 2020? 2020, now the private investors backed off a bit because of COVID crisis and everything, because people not sure what's going to happen with the economic outlook. But at the same time, the governments, they started putting in a lot of money um, in AI and in related fields, because if there's a if the government is putting in some money, that will kickstart the investment process from private people as well. So the amount of investment is more or less the same as 2019, just because governments are putting in lots of investment when it comes to AI. Yeah, this field is actually the same one. Um, so, so if you use your chat box, and I'm going to ask you something like, um, for since you know something about AI, and that's one of the reasons why you're in this class, which which field of AI, and now I'm talking about machine learning, deep learning, and natural language processing, which field of AI do you think is the most important one? Um, just use the chat box and try to answer over there. Either write machine learning, deep learning, or natural language processing. Hmm. You know, of a class of almost 71 participants who are active right now, only 3 have replied. Okay, but that's fine. 3 is, I can accept that. 3, fourth, yay. I have a 4th person coming in and very in doubt. Okay. Hmm. Okay, so 6 people who have replied, like half of them are focusing on NLP. The rest of you agree? Okay, cool. So, all right, so let's say half now, 50-50, right? 50% say it's natural language processing and 50% say it's deep learning. Um, so when it comes to research in AI, deep learning is used a lot. So yes, I do agree with this. When it comes to corporates, when it comes to corporate, like organizations and everything, they're using a lot of machine learning and they're using a lot of natural language processing. Uh, Especially now, natural language processing is being used a lot because the problem the problem in Scandinavia, or the problem with every country, European country who have their own language, is that that's Germany, that's Netherlands, Norway, Sweden, Finland, who have their own language in addition to English language, is that it's very hard for them to use the algorithms, NLP algorithms, because those algorithms work very well for English language, but they do not work very well for, they might not work as well for Norwegian, Swedish, German language, and so on. So there's a lot of work being done, and I mean, if you talk about organizations, what do organizations do the most? One thing common in every organization is, you know what? I'll ask you. So if it comes to NLP, if if all organizations are using natural language processing, what's the business case they are using? And all of them have the same common business case. Use the chat to answer. This is something we discussed in the last class too, when we spoke about statistics, and I showed you the biggest automation being done is interesting. So the okay, processing data from different languages. Huh. So 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 let's take an example. So let's take an example of Nav, Skattetaten, and Ruter. Nav is a social security company. It helps people giving out social payments from everything, right? From sick payments to unemployment and parental benefits, everything. Then you have Skattetaten, which works in the opposite way. It collects taxes. It's a different kind of business model. And then you have Ruter, totally again different kind of business model. Ruter works on providing transport services to all the users. Now, of course, there are many similarities, and all of the points you have mentioned are very valid because all of them are working with exactly the same thing: customer support, translation and global communication, and processing data from different languages. Correct. Um, uh, from my perspective, what I was also thinking was that all of these companies have users, and when it comes to users from the natural language perspective, all of them have to communicate with their end users. So that would be the customer service department, customer support. So then all of these companies receive a lot of emails. They receive a lot of calls. They receive a lot of questions, and they have to answer them as best as possible. So naturally, a lot of natural language processing and AI automation is being done in the customer service department. And that's not common with all these three companies. That's common with almost every company inside Norway. I have seen a huge rise in NLP in the last 1 to 2 years. Even Ruther, even my team is working on an NLP project now, which is almost done, and I'll actually give you a presentation of that later in the classes. So and the other thing all companies are working on is the machine learning. Deep learning, I've not really seen deep learning being used in corporations, private companies, but when it comes to research organizations, they're using a lot of deep learning because their data is humongous. Their research problems are very special, and they are well advanced in the future than the rest of us. Okay, let's see. So we have defined what an AI is. We have also discussed the buzzwords around AI, what AI can do, what it cannot do. So then I'm going to ask another question. I want you to identify a company which is purely an AI company. Now, this is based on the same factor as I discussed earlier. Like some companies, they call themselves an AI company, and they pitch themselves like, we are an AI company and we are creating this, and this. I think that's wrong, but I might be wrong as well. So how about I wanted to ask you, like, can you identify any AI company which you think is a pure AI company, which only creates AI applications or AI hardware, for example? Hmm. Open AI. Good answer. Yeah. Anyone else? Would do you think we would call Google as an AI company, or Facebook or Twitter as an AI company? Hmm. DeepMind, yes, correct. Yeah, agreed, right? So these companies, Spacemaker. What's Spacemaker? I've never heard of Spacemaker. Hmm. Not really, because they offer many other services. They also use for like, yes, correct, correct. Mm, mm, agreed. And this is Azati. Huh, never heard of that. I need to search up on Spacemaker Azati. Okay, nice. Thank you for the explanation. Right. I agree. I totally agree. So when it comes to OpenAI, DeepMind, these are AI research institutes. And yes, you're right. They are working purely on AI. When it comes to private organizations, there's no non-research institutions. Then it's very hard to identify if you really have an AI company. The other day, I heard about this chip-based AI company, uh, and I'm not thinking straight right now because I don't remember its name. Um, but they have one of their offices in Norway as well. Um, they're they're making hardware based just which is used for AI applications. Now, this is a huge question mark. Would you call them an AI company because they're making AI hardware, or is their product is actually a chip, uh, which also supports AI applications? Um, like Intel, they don't call themselves. They call themselves the chip company. They don't call themselves a software chip company because chip can be used for anything. Um, so you as the students of the AI class needs to identify between what an AI company is and what's not an AI company. You will meet a lot of startups trying to recruit you, and all of them will tell you, "Oh, we are an AI company." You have to be smarter than them. You have to tell them that no, you're not an AI company because your actual product is not an AI product. Most of the companies who make a product are not, it's not really an AI product. If you're creating an AI based smartphone, that's just stupid. You're creating a smartphone which might have AI in it, which can do some AI things as well. um, so don't get sold on the idea that this is an AI company. Be If someone is selling you on this idea that they have an AI company, they don't really know what they are talking about, and you have to be careful joining that company. Okay. In Correct. That's very good. Yeah, AI is just a tool to improve the main product for private organizations. Thank you for saying that. And that's my point as well. AI is just a service. It's just another service which helps other software services do their job in a much and improved way. Um, and if we understand this right, then we take AI out of its black box and we put it more in the same era or same area where we put other software applications. Then we don't consider AI as like the all something which can solve everything, but we actually understand the limitations of AI, and we identify what can be done with AI and what cannot be done with AI. Not everything can be solved with AI, and that's the whole point of this class. That yes, AI is very attractive. There's a lot of money going in AI, but AI has its drawbacks as well, and AI might not be a solution to everyone. Uh, yeah. So a few examples of artificial intelligence in our daily lives. You saw, I mean, this calculator, all of us have used this kind of calculator. And we all know that this is not really a smart calculator. There's no AI in it. It's just scientific calculations. Just the processing you give it, we have predefined processing in the calculator. So we cannot really call it an AI-based calculator. Similarly, a simple camera we had like before 2000, it didn't have any AI in it. but the cameras we have now has a lot of AI in it. So you can easily distinguish what product has AI in it and what product does not, because this camera which we had from a long time ago, it cannot do image processing. It cannot identify a person as a person by drawing a box on them. But this camera can. This camera can distinguish a male from a female, distinguish a person from a set of different objects, for example. There is AI in this kind of camera. Then we have, yes, Apple Siri and Google Home is defined as AI. I'm going to come to that. That's also part of the slide. So when it comes to chips, it's important to identify which chips support AI and which chips do not support AI. Until 2000, a lot of chips were just simple chips. They were working for CPUs. You had chips which were for games, and but then most recently now, like I think from 2010 and onwards, we are seeing a huge rise in AI-based chips. And you know, the biggest investment going in right now, in my opinion, is in AI-based hardware. There's a lot of money going in, and the reason is that the chip business is very hard. It's very hard to start up. Once you are able to start it up, because there's a lot of supply chain involved, there's a lot of talent you have to acquire. But once you set it up and you define it for AI specifically, you will make investors go really crazy for that kind of startup. And then you had an iPod. Yeah, that's an iPod. Then you had an iPod. Now, I don't think an iPod ever had AI in it, because again, it was a set of instructions, automatically programmed. You had a playlist. You could play those playlists, but there was no AI in it. So that was also just a simple product, not using AI. But the other example of AI in our daily lives is self-driving cars. We have seen a lot of self-driving cars coming out. We do not see a lot of them in Norway. Oh, we do, actually. Ruther has a few self-driving buses. Has anyone of you tried those? Has anyone tried? Oh, how was your experience? Was it good or bad? How did it go? I haven't tried them. Yeah, I heard that. They're slow as hell. Oh, self-driving cars. Never heard them before. At the airport. Self-driving buses at the airport. Okay. Barcelona. Nice. I haven't tried those. I mean, I know Ruther is experimenting in 2 more zones for self-driving buses. That project is not really under my department, but what we do is we don't build our own self-driving cars. We just buy them from a company based in Denmark and Finland, and we test them out. So please do not blame us for the buses being slow, because we don't have any control of how they're operated. We're only responsible for collecting the data and providing good services to everyone in Oslo and Viken. But I mean, they're improving, right? So they're continuously trying to improve these things. We hope, all of us hope, that we can have self-driving cars. So it will make things much more easier for everyone. But it's not something we have achieved now, but we are working towards that goal. What we do have achieved is image and video analysis. This is something really cool. It's cool and scary at the same time, because if you go to some countries, they are misusing image and video analysis, but other countries are also using it for safer purposes. I think Norway is a very good example when it comes to safe use of image and video analysis, that it's being used for actually, it's being used to protect the country and to not like, not to use it to actually oppress anyone. But then when it comes to identifying how many how the crops could be done, how the land deteriorates over time. A lot of satellite images, satellites are using AI to do that as well. Yeah. Then when it comes to voice and chat assistants, all of the voice assistants we see today, Google Home, Amazon Alexa, Apple Siri, all of them are AI-based assistants. So again, you wouldn't call them as AI products. They're just smart speakers which have AI in them. These companies were very, these companies when they have such a big organization, they don't use the word AI so freely because they have actually a marketing department, a sales department, which focuses on how you can effectively use these terms. So they focus on smart speakers. They don't say AI-based speakers. AI is an element of those smart devices. Why do they call them smart devices? Because they're connected to the internet. They can play content from your phone. They have apps in them, and they also use AI to talk back to you and understand what you're talking about. Then we have also seen chatbots. Okay. Hmm. How many? So by raising your hands, how many of you think chatbots are amazing, or they are the future, or they will change how we work? No one raised their hand. Okay. How many of you think chatbots are stupid? All right. A lot of people are raising their hands. I kind of agree with you. I do agree. Chatbots are, I don't know how they kicked off. I don't know why we're using them. Um, but if you look at the money going in every organization on how they're doing automation with chatbot, you will be amazed. Uh, the biggest corporations in Norway and around the world, all of them are working on chatbots. Everyone wants to have a chatbot in their customer service. And even though the end users, as us, we get annoyed when we talk with the chatbot, they are here to stay. Um, so this is one example which I don't understand about technology. Like this is of all the people I've spoken to, my own personal experience, and I ask this question everywhere, wherever I go, like, what do you think about chatbots? I get the same answer. People are annoyed. They don't like chatbots. But the promise of the chatbots, the reason why companies still use chatbots is because it gives them a promise. It gives them a promise that this can deliver something sometime in the future. And 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 companies are holding on to that promise that when that future comes, then they will be ready enough to make that move. Um, Yeah, so Adrian, yeah, it's a good point you make that companies, yes, private companies are focused on reducing their headcount, but the problem is when you install a chatbot, you have to continuously train it. So at one moment, at one side, you decrease your customer service personnel, but on the other hand, you hire more AI trainers to train the chatbot. So I don't know how beneficial it is for the company because it's a huge investment to hire AI trainers and then buy the software for someone else and develop the software. Whereas actually simpler and easier to, but I guess automation is kind of like that. You invest in automation, the initial investment is really huge, but it gives you some benefit later down the process. And that's what all companies are hoping for, that within a few years, when AI processes increase more, then they will actually replace humans. Huh. I think Shiraz, all right. Chatbot can reduce the cost of small organizations where they can buy services from things. Yeah, okay. Yeah, that's a good point as well, Shiraz. Mm. But I guess we'll just have to see how this evolves. We did a very cool project at Router. So what we did was we instead of making a chat bot, we created an email bot. So you know when the bus is delayed or the bus is not arriving on time, you probably get angry and you probably open up router.no and you launch a complaint, or you call them and you're like, where's the bus? It hasn't arrived and blah, blah, blah. And they will be like, all right, if it's more delayed than 20 minutes, will compensate you, or they'll tell you, don't worry, the bus is on its way. The bus is arriving. Sometimes you don't call, sometimes you send us an email. So what we did was we used natural language processing to understand what is the customer talking about, what are they complaining about, and then we use an email bot to reply to that incoming message. The benefit of using an email bot is that it kind of hides that this is actually an email bot. It hides away the frustration of using a chat bot, and it gives you a quick answer. So if you are standing on the stop and you're like, where's my bus? Instead of a human who will actually answer your message in a few hours, in a few minutes or a few hours, depending on the load, you will get an answer immediately. The bot will go in, check the status of the bus, and will come back to you saying like the bus will be there in a few minutes, or sorry, it's delayed. We can compensate you, for example. Thank you. Knowing the struggles of depending on music. Hey, we understand the problems. We understand. We see the complaints coming in from the users. So we are really trying to improve our services. So no one ignores it, just to let you know. And if we ignore it, we come in the newspaper, and it's not a nice thing because Router is still an off-friendly company. So we are supposed to, off-friendly companies have the same objective, right? They have to help the people out. If the people are angry and frustrated, then it kind of destroys the whole concept of being an off-friendly organization. We actually have a presentation on the work we have done at Router. So one of the days I'm going to upload that. That would be our mini class. Few more examples of AI in our daily lives. I see the time is really flying. So what I'm going to do is, if you want to leave, you can leave the class now, but I'll continue teaching. So this recording will still be there. There's a lab session coming afterwards, which will start around at, I think it's going to start at 11:15 or 11 o'clock. Yes, it's going to start at 11. I haven't uploaded it yet, but I will upload it and send it to you. So let's come back to the class. So a few examples of AI, how we use in our daily lives is we use Google Maps. There's a lot of artificial intelligence in it. Even the route optimization uses a lot of AI. Uber uses a lot of AI when it comes to calculation of how much money you have to pay, depending on, because you know, if it's raining somewhere, you probably have to pay a huge price. How would Uber know that? Is Uber kind of calculates it in advance, so they know in advance where it's going to rain through AI, and they can actually redirect. Yeah, I don't know if they can redirect their cabs over there, but at least they know that the demand in advance, they can forecast it. The spam filter in our emails, that's based on AI. That was a very early examples of how AI was used practically in emails. And in the university, like in most of the universities, if you want to check if someone has copied some other person's work, we use a lot of AI there as well. A lot of softwares we use, they have built-in AI in them. That also makes it easier for the teachers to check if there's a problem, if someone has copied it or not. One of the biggest examples of AI, which I think is so exciting and so cool, is content recommendation. And this is the key. This is the key on how Facebook is doing a better job than TikTok or Snapchat or Instagram or Amazon. It's based on content recommendation. What is content recommendation? A content recommendation is that if I and you both have an account on Facebook, The feeds on my Facebook will be different from feeds on your Facebook. And that's because the content on both of our feeds is based on our interest, our friends, um, the clicks we have done, the pages we have visited. So all of that history is maintained. And based on that history, Facebook then knows what kind of content they could recommend back to us. The same goes for TikTok. I haven't used TikTok. I'm very old for TikTok. I haven't really used it. And I'm kind of tired of using social media apps. But I'm assuming TikTok is using the same when it comes to recommending videos back to the user. Instagram I use. So Instagram, I know that based on your likes, it based on your likes, based on what you see, based on videos around you, it can also recommend what kind of videos or pictures you would be interested in. This prediction is done on the fly. This prediction is done based on what you click now, and then the recommendation engine or the content will be updated. Same goes for Amazon, Apple Store, Google Play. Now, all of the tech companies who have a product which is a consumer related product, every one of them wants to work on content recommendation. And that's the key. If you get content recommendation right, you excel as a consumer company. And if you fall back on the content recommendation, then some other competitor will come in and they will take the game from you. Let's talk about different types of artificial intelligence. We have three major types. You have narrow AI, general AI, and super AI. Now, the thing with the narrow AI is that narrow AI is the one which we use most of the time in our daily life. You have an AI powered camera. That's a narrow AI. That's dedicated to one small task, and we work only on that task. You have headphones which kind of have Siri or Google Voice Assistant in them. That's also an example of a specific use case. So narrow AI is the category of devices which pick up one problem and solve that problem only. A general AI is an AI which would work on more than one issues and try to solve those issues together by combining knowledge from one problem to the other. And then you have super AI. Super AI is something which we haven't really achieved now, but this is something which is much more advanced than humans can ever be. And the example of narrow AI are chatbots, voice assistant, general machine learning applications. Whereas the example of general AI, can anyone give me an example of general AI? Something you think is working on different problems, solving it at the same time, and yeah, can anyone give me that? No? Okay. Google speech recognition software. Hall 9000. Hall 9000. Is that from the movie? Hall 9000? Let me check what Hall 9000 is. I think it is from the movie. Yes. Yeah, Hall 9. Yeah, well, the whole Hal 9000 was a super AI. That's from the movie. What was the name of the movie? I don't remember. Space Odyssey. Thank you. 2001 Space Odyssey. General AI, natural language processing. Okay, these natural language processing, this is the fields, right? So these are mostly algorithms or areas you can use to create applications. Those applications which you create then fall into either narrow AI, general AI, or super AI. So the tools itself cannot be considered a category of those. But speech recognition software, yes, that can be considered. But then again, a speech recognition software is also a very general category. But inside a speech recognition software, you could say that Google Duplex, I don't know if you've heard of that, they claim to have reached a general AI. I'll give you an example of that. Before we give an example of that one, let's talk about the Turing test. A Turing test is very important to identify. H plus one, A plus one, and B one, this side. um, the Turing test is kind of um, so if a system or a machine passes a Turing test, then it's can claim then that system can claim to have general AI. So what is a Turing test? So you have a human B and C, and the human which is on the C has to read. It has no idea. The human on the C part knows that there's an input coming from a machine, um, and a human, but the human has no idea which one is the machine and which one is the human. So both A and B are given the same set of questions. They have to answer the same set of questions with the same set of information, and then the evaluator has to evaluate those answers and then see which of them was a human, or which of them was a machine. That's called a Turing test. So if the machine is able to fool the evaluator, and the evaluator thinks that the machine is actually a human, then that machine has passed a general AI test. Yeah, you could say Google Translate is also one of those. Yeah, you could claim that actually. Now, but can we say that modern AI assistants like Siri or chatbots or Google Voice Assistant, um, or Amazon Alexa, do you think they can pass the Turing test? Like, can they fool people into thinking they are like a general AI? Ah, don't be scared of the computer passing, but be terrified of them. Yeah. So my answer to this, my own question is no. I don't think modern assistant can pass the Turing test, because when you ask them a question, they will get confused. Sometimes, yeah, some of the questions are very easy to answer. Yes, some of them are. Thank you, Shiraz. Some of them, you're right. Some of them, most of them fail. But you cannot have a proper conversation with Siri or actually any other voice assistant. They will fail at some point, and they actually claim that they're not really focused on Turing tests. But Google kind of continued working on their duplex, and they claim that they actually their voice assistant, and they claim that they have passed the general AI. This is a YouTube video, right? So I'm going to play this. So if you cannot hear it, let me know. Do you hear it? Do you hear the audio? No. How should I do this? How should I do this? Hmm. You have to click on share computer assignment, sharing screen, I think. Okay. Hear it now? Nice. All right. So I've taken off my headphones, so now you'll be able to hear it. Let's see. This is a presentation by Google. I've just plugged it in. Just to highlight it over here, the Google Assistant is on the one indicated with the dots, and the human person is on the right-hand side. So this is an example of actual call Google Assistant made to a human person somewhere for like scheduling a call. What they also tried to show was that this assistant um, was capable of placing a call without any human intervention, and it kind of fooled the human into believing that this was an actual human making a call.
We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now? Okay, we have it 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks, great. Have a great day then. Hey, how may I hear you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people when?
Next Wednesday at 6 p.m.
Oh, actually, we need to go like after like 5 people. For 4 people, you can come.
How long is the wait usually to be seated?
When tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Bye-bye.
That's a very good example, right? I mean, we can see that, and that's what Google Duplex kind of claims, that they have a voice assistant which has exceeded normal AI and more narrow AI and go on to actually claiming general AI. I think this is actually pretty cool, but of course this can be used for some kind of wrong things as well. Anyway, so the branches of AI. We've been talking a lot about machine learning, deep learning. You have the artificial intelligence, which is the main field. Then you had subfields in AI, which would be the machine learning. What really is machine learning? Machine learning, we'll cover more machine learning later, but this is like you're trying to create algorithms without explicitly programming them. But of course, then it becomes more complicated. And then you have a subfield of machine learning, which is called deep learning, which is machine learning, but stack over multiple layers. You go down and down and retrain, and that's deep learning. And then you have data science, something I really like. Data science is kind of not really, it's interrelated to AI, but not really part of AI. It's on the side, but uses some of the elements of deep learning, machine learning, and AI. We'll cover deep data science as well. Then you have natural language processes, which is a core part of AI. Natural language processing focuses only on text, speech, for example. Then you have robotics, people who are working with hardware element of AI, vision, focusing on image processing, speech processing, for example, and so on. There are many branches of AI which you can identify. For the context of this class, we will focus on these branches. We might not dive into deep learning, but we will dive into machine learning, natural language processing, and data science. All right. Let's talk about the skill sets needed to work with AI. They say that you need to have maths, and that is correct. You need to have maths, but in my opinion and my practical experience, if you do not have a good enough understanding of math, it's totally fine. If you want to work with AI research, yes, then you need math. But with day-to-day working in the industry, like making machine learning programs, natural language applications, it's nice to know basic math, but you don't need to know like the AI specific math. That's not really needed. Statistics is very important. The reason is that when you look at data, you need to know uh, terminologies of statistics, how to take away the data sets, what are the outliers of the data set, how to identify good data and bad data. Statistics actually helps. So if you can actually focus on that, that would be nice. Machine learning is actually needed when it comes to yeah, AI. Machine learning is actually needed the most. Statistical programming, since most of the people who work with AI work with Python, um, it's kind of a requirement that you should know how different Python packages in statistical programming work, like scikit-learn, pandas. These are the two most important packages, well-known packages in uh, Python. Um, and then we have software engineering. I think this is the most important thing when it comes to working with AI, because you can make a software application, you can make an AI application, but if you don't know how to deploy it, how to optimize the code, how to rerun it, how to deploy it into production, um, and how to scale up or scale it down, the whole point of working with the AI application fails. So it's more beneficial for software engineers to learn AI, in my opinion, um, because they already know the concept of computer science and how to build software than the other way around. A lot of AI has created a lot of AI buzz has created a lot of negativity as well. You have the fear of missing out. People are like, "What's AI? What can an AI do for me?" Then you have organizations jumping onto AI. We want to do AI. How about we implement AI? So without even analyzing or doing a proper investigation of do you need AI, what AI really stands for, people are like, that's a fear of missing out, FOMO as we may call it. Then it has also created a lot of fear, uncertainty, and doubt. People think it's going to take away their jobs. People think it's going to kill all the humans, and people don't know how the future will look with AI. I mean, this is the same feud we had when industrial revolutions were happening, electricity revolution was happening. Yes, the jobs are taken away, but they're also transformed into something new. Different kind of economy comes around. And the last one is feuds. Like it's when people who have some knowledge of AI and some philosophy of AI, they start to fight with each other over in public. And the famous example is Mark Zuckerberg, founder of Facebook, and Elon Musk, who is the founder of Tesla. And what they do is they fight with each other. Elon thinks AI will destroy everyone, all humanity. Mark thinks AI still hasn't reached its goal yet, and we're very far away, and AI cannot really do this. So people fight over this, and they think they know everything, and yeah, and then media also highlights them. If I were to ask you, whom would you side with? Do you think Mark Zuckerberg, Facebook guy, says the right way when it says that AI is not really advanced yet, or do you think Elon Musk is saying the right thing when he says that AI is dangerous for us? So use the chat bot and use the chat and to give me your feedback. Team Elon. All right. I don't know why people hate him. Mark Zuckerberg. Okay, I see. Yeah, that's true. I don't know. Big capitalist. Yeah. Hmm. Yeah, but I mean, all of them are big capitalists. All of the founders, all of the startups are capitalist startups. That's their whole motto. They want to create more money. Yeah, but some of them are pretty good. Mozilla Foundation is actually pretty good. Okay, thank you for clarifying about Alan. Um, okay. Yeah, that's true, Shiraz. Okay, my opinion, I would side with Mark. I think AI is not really that advanced yet. We're still working on a very we have just now achieved general AI. But having said that, we don't know how the future will be. AI is not that advanced that it can kill humans, but it is, we are, we still have a lot to discover. And Shiraz is right. Yes, Facebook created their own, they're working with their chat bots and they created their own language and they had to shut down the project. A very cool case story, actually. But then the AI buzz has also helped us solve many problems. For example, I don't know if many of you know, but human trafficking still is a huge problem. A lot of people are still being sold for slavery, various kind of slavery. And there are huge amounts of investigation being done with different areas of different governments, and they're using AI. For example, the picture you see over here, one of the things is that people who are sold for sex trafficking, um, uh, they when they're sold for sex trafficking, of course they come equipped with. I mean, they have to have a certain space where people can go and use them. So what they try to do is the way these investigators identify if a specific hotel is being used for sex trafficking is that they identify how the room is advertised in the pictures online, and they look at how people were sleeping on the room, how things were organized. There's a difference in a way how a room will be organized when people will stay just for normal um, staying, and if a room is being used for sex purposes only. Um, and they try to identify patterns on those pictures, and then if they identify the same pattern, they can identify those hotels. And once they identify the hotel, they can identify the individuals using them and try to locate those. It's a very complex thing, actually. Um, but human trafficking is actually a very good example where AI buzz has helped a lot. Money laundering. Now, money laundering is also very connected with human trafficking. A lot of the banks who use AI they also try to identify patterns or to see where the money is coming and going from. I don't know if you ever spend any money abroad, but since most of my family is abroad, I usually spend some money abroad. Sometimes I get a lot of questions on why. It's annoying, but I understand why they're asking these many questions, because at the back end, they have to identify different trails and they have to see where the money originated from, where it's going, if it's used for the right purposes or not. And if it raises a red flag, then they identify the authorities. Um, Now, when it comes to terrorism, yes, a lot of it is being used now. So you go to UK, you see a lot of cameras everywhere in London. That's one of the reasons why they are doing is to identify possible security threats. It helps. It actually does help. Then a lot of companies, defense companies, are using satellite images to identify the movement, um, also to identify possible attacks in the country. The COVID-19 research right now is using a lot of AI to gather data to identify patterns, to see problems with the patients. They're actively using AI in the research areas. So I mean, yes, it has created a lot of problems, the AI buzz, but it's also creating a lot of possibilities to solve our current issues, which we are not able to solve in our normal ways. So yeah, I think this is it. This is the slide. So let me stop sharing. No, not this. Stop sharing. Yeah. Hmm. All right. So that was the lecture we had for today. We have a lab. What I'll do is, again, I'm going to take a 15 minutes break. We'll meet back at 11 o'clock. I'm going to stop recording now. But what we're going to do with the lab is the lab is very simple. You have to create your own Python environment. You have to create, you have to install Conda, or you have to Anaconda, or you have to install Miniconda. And then you have to see if you have a Jupyter notebook, which actually works. But before we do that, Jacob raised their hand. Do you have anything to say, Jacob? I saw you raise your hand. I don't know if you. Okay, I thought probably that's a long. Oh, no worries. Thank you. Typical labs. What is happening? 1 second, everyone. I have a few questions regarding the lab, but let's do it in 15 minutes or 10 more minutes. I'm gonna stop the recording over here now, but I'll keep Zoom on. So please stay here and then we'll meet again. All right.